Welcome. It is my pleasure to introduce Earl Girbovan, Master Model Railroader.
So we're on to my screen, right?
You want to turn your video on too?
The computer doesn't like it sometime, but I'm sharing the screen, right?
Yes.
Okay, thank you. So I've got two big projects and one kind of smaller project that I've been working on that I kind of want to talk to you guys about. So I'm in the process of working on a home layout, and the home layouts can have a combination of standard gauge and narrow gauge. And the narrow gauge is going to run between two towns. And I don't like running steam engines backward. I know the prototype does, but I really don't like running them backward. Plus, I have a galloping goose that running backwards is going to look funny. So I went looking for a narrow gauge turntable and came across Otter Creek Railroad on YouTube. And he's got actually 3 videos about building the Kitwood Hills turntable. And, Ken was just talking about British modelers. This is a British firm, and it's a guy, little garage shop guy, that makes these, a batch at a time. And the kit's been fantastic. I actually bought 2 of them because I want to be able to turn the locomotive in each town. So this is the website for Kitwood Hill. He makes a lot of different things along with the turntable. And then this is, the various turntables in both HO and O scale. And I ordered it. It took him, I think, a month and a half to get into the batch that he was making, and about a week and a half for it to be shipped from England. So actually came over really quick. The interesting thing with Otter Creek, if you look at the picture on the right, Alan Loazzo, if the name sounds familiar or the railroad in the background looks familiar, Alan Loazzo is Ed Loazzo's son. And you guys know Ed Loazzo here in Los Altos as a resident S scale guy.
Oh, yes.
So Alan's actually a N&W engineer living in North Carolina, and he has a side business now of making fast tracks, turnouts, and selling them on the web. So I know a lot of the O-scalers know him because he makes, narrow gauge turnouts, but he's got these things on the web, and what I've heard so far is he actually does a pretty good job of them, and you can get on his website and order them. So the turntable from Kitwood Hill starts off, this is like the beginning of the kit, and you can see everything's really, really nicely cut and etched plywood. The bigger circle, you can see where the ring rail goes. The solid thing is the pit for the turntable. And you see some holes, and I'll show them to you again later. These are alignment holes for, you see the pinholes here. There's a lot of alignment and fixturing and tooling built into this, so it makes the assembly really easy. So once you glue it all together and paint it and kind of get ready to attach the ring rail, this is what it looks like. I wanted to model one of them with a concrete ring, so all the little tie pieces are glued to, the ring painted gray and weathered to look like concrete. So this is kind of like building a fast tracks thing where you glue down some PCB ties, then you glue down some sleeper ties, then you solder it all together. They give you a pre-bent ring rail, and it wasn't a small enough radius, so I got a hold of a rail bender and just kept running the ring down till it looked like it was about the right diameter. Because, when you solder this, you really don't want to stress it. You really want this, the ring to be concentric. Back to those tooling holes. So they give you a fixture that you kind of glue together. You can see the little splice plates. And this is the template to solder in the ring rail. And you start off by soldering, one end and kind of working your way around. And I did like every other tie, then came back and filled in. And when it's done, it looks like this. You've got a really perfectly concentric ring rail. The other thing that he suggests, and I did, is put a double tie where the splice is. So you're not heating up an old joint and shifting things around. This actually went really quickly. There's a couple little holes here, and I'll talk about these again in a minute. These are plungers for electrical contact. The problem with most turntables is electrical contact. You got a wiper on the ring rail, you're maybe doing the center shaft, and those things just never seem to work right. So he's got these electrical plungers, and I'll show you another part in a minute that really do good with electrical. So this rail on top is the top of the pit wall, and you see some posts that are glued into laser cut holes, and these posts get glued into these notches around the perimeter of the pit. And then he's got some laser cut sleepers that kind of go in and fill in between all that. And again, the bushing for the motor shaft. And then, the ring just flips over, glues into this. So I didn't have a good picture when I built it because I was too far along, but this is what the whole center looks like with these little plungers. And you just solder some wires underneath the board. And this is really the most critical part of the kit, I think, this bearing assembly of the center shaft. This comes pre-assembled. I'll show you the other side in another slide, but you can see it's a PCB with concentric rings, and this is what the little plungers ride on. The interesting thing, this guy must spend years boxing this kit up. Every little set of sub-assemblies is in a bag, and this is the motor mount bag down here with the motor mounts. You can see it's all tab, it all tab and slot, everything fits. And then the small parts are even bagged within the bag. So he gives you extra parts, extra screws. It's kind of really nice. Keeps the carpet from eating all the parts that you drop. So you buy the motor separate. So you go onto eBay or Amazon and buy this little gear motor. And this motor works really well. His tooling is all set up for the screw holes. Everything seems to fit, and it's already, a bit over half an RPM. So it's the right speed. The next thing in the kit assembly is mounting the track on the turntable itself. And you got to solder some feeder wires on there. The cutouts in the turntable for the feeder wires, there's not a lot of slot. You really have to have them pretty well positioned. And you can see with the arrows, there's not a lot of room if you make a mistake. So what I did is came up with a little fixturing kind of thing. I got the blue wire soldered on there, and you can see at the tip of the red arrow, there's a little mark on the rail where I have to solder the other wire. And I really didn't think that I could keep it lined up and not lose the position. So the tooling block kind of points to where the wire has to get soldered. So I was able to solder it exactly where I needed it soldered, and everything seemed to fit really well. So this is the other side of that center shaft that I showed you. And the top side has this kind of a split PCB assembly. So you solder, the track feeders to that. The center shaft, comes through. This is a brass block, and then this is a wood spacer. So this thing comes epoxied, pre-assembled. Everything is straight and square and plumb. So it's really nice. He gives you this part pre-assembled. And then the wood part keys into this square part down here. And you can see there's kind of a long side, a short side. a short side. So the wires kind of all get jammed up inside here, and then this kind of locks onto the bridge. So when you build it, you don't glue this to this, just the friction holds it in place. And the turntable really revolves on the rollers. So they're, I think, 3D printed rollers. They're on little metal axles that you glue in. And, even first time out the chute, it just ran really well for me. He also gives you, so this is everything kind of put together, kind of a test pass. He also gives you some alignment fixture, an alignment fixture. The problem is getting the rails centered so that when you turn the turntable, they end up in the same place. So the masking tape is holding some pins that tend to fall through, but the little spacer here, you line it up, spin the turntable around, make sure it lines on the other side. If you're happy, you super glue the rails in place, and you got a turntable with everything lined up. One of the things when I was watching the Otter Creek fella, and again, if this turntable is at all interesting to you, I really suggest watching. He's got 3 videos. It's a really good step-by-step on how to assemble it. And I've referred back to that video a number of times. When you glue in these gallows supports, it's all end grain and there's not really much strength. So he suggested, and I did also, is I pinned the centerpiece. It's just to hold it in place because you work on these things, you bump it, it falls apart, and you say bad words. So this kind of held everything together when I was fitting things. The next thing is gluing, is forming the support rods, the truss rods. And he got me a little bit nervous when I watched the video saying, it was really difficult. It was frustrating for him to do. So I didn't want to get tied up in that. And he also mentioned he seemed to have to handle everything a lot. And I really didn't want to be handling everything. So I made up a template in PowerPoint. And, Phil talks a lot about PowerPoint as a modeling tool, and I use it quite a bit also. So I measured where the ties are, and that's what these little rectangles at the bottom are. These are, where the lengths I needed. Drew in the little tie pieces, drew in where the truss rods had to be bent to, and sat down and bent up a bunch of truss rods. This actually went pretty well because once you bend up one, you use it as a template to build up the others. And there's some give. There's not a lot of give, but there's some give in bending these and fitting them. But this actually worked out well. It actually went a lot faster than I thought it was going to go. The only thing I had to do is mark where the intermediate truss rod poked through, because you have to count ties each way, and when you're in the heat of the moment, you miscount the number of ties, then things are lopsided. So I put a couple of pieces of tape so I didn't screw up too bad. And this is what it looks like with all the truss rods in place. And I built up. This is on top of a little fixture I made that I can drop the turntable in and spin it around and all that. And so this is the turntable going. So this is the 0.6 RPM motor. And it's a pretty reasonable speed, maybe a touch fast. I didn't really have a feel for how fast 0.6 RPM was, but that's, a pretty good speed. So that's the turntable. And you can see I kind of, weathered the pit, did some dirt and things like that. So I got one down and one to go. So any questions on the turntable before I go into the next part?
Earl, could
Yeah.
you up the URL or something for his website. I want to see if he has something that it would work with a standard gauge model.
Okay.
Not of a gallows type turntable, but a full pit bridge type turntable.
Okay. It's Kitwood Hill. If you just web search Kitwood Hills, it pops right up. But I'll try to after I'm done with all this. So next
I threw a link in the chat.
Cool. Thank you, Phil.
Yeah.
So next project is Milpitas Materials. This is a project for Seth Newman's layout. And this is another one of those things where, oh yeah, just a few pieces to fit together and we'll have a nice model. Should only take you a month. Vis-a-vis the gravel crusher I did. So this is the batch plant over in Milpitas. And we've got a few pretty good photos of the plant itself. You know, front view, this is the back view. They have kind of a side view. So we kind of know what the plant is. The problem is we don't have a lot of detailed pictures and we don't really have any real dimensions to work from. You know, there's nothing in here that is X feet wide. So we started off, and this has been on the layout for a while, of taking those pictures, blowing them up to sort of HO scale, gluing them on some foam core, and this has been the industry for quite a while, stuck back in the corner. But, you know, kind of a good place to start. It was hard, the first time trying to conceptualize this thing and really see the angles and how things fit together. So I sat down with a knife and a bunch of foam core and a hot glue gun and started mocking things up. You got to start somewhere, got to see how much space we had, scaling it to a cement truck that you'll maybe see in another picture. And at least this way we had a feel for how things looked. But, I tried drawing it 2D and you can't draw 2D because there's too many things going on. So got into Tinkercad and I drew up a model in Tinkercad. And this kind of gave us a base to start from. But as we were looking at it, we didn't have a plan view. So we really didn't know how things fit together, how the bins overlap, the relative size and all that. So we got onto Google and were able to get kind of a plan view. And it actually worked out good because we didn't realize that those bins are split into two portions. And you can see the dividers if you look at these pictures long enough. And then we got the details for the conveyor system. You can see there's diverters that drop it into the different bins. That actually worked out really good because I'll show you in a minute, we could put a divider in the middle of the bin, which really strengthened the bin. And then we got some ideas for details for all the tanks and things that are around the main building. So this is the first print out of the chute. And you can see this is the divider, which strengthens it. These are supports for the diverters. I looked at scratch building the bins out of styrene, and I really didn't think I could do a good job, with the angles and fitting everything, and just decided going to 3D print the whole thing. The other thing we looked at, this is that kind of shed section below. So the legs fit up into 3D printed slots. They're just friction fits. And this whole thing is going to be a sub-assembly. There's two bins, and I'll talk about the other bin in a minute, but I'm trying to keep it as two sub-assemblies, and then I can sheathe this with the right sheathing, put the right roof on, and then go back and hang piping and supports and everything off of it. So this is actually good to build a first article, because then when we tried to drive a truck under it, the legs were too close together and you couldn't fit a truck underneath. So it also, the proportions weren't right and couldn't really figure out what was going on. So I went back to Tinkercad and started playing with the drawing that I did, and then took a look at the back view. So we had a good back view of the whole structure. And the nice thing you can do with PowerPoint and Tinkercad is I could overlay this thing that I drew onto the model or onto the prototype. And you can see, okay, the width is about right. The height is about right. These things kind of line up. The angle's pretty close. So I was pretty comfortable. Yeah. Sorry, I jumped ahead. So I was pretty comfortable with finally getting the right proportions on the model. So I went back to Tinkercad and redrew or modified the slope angles, modified this. I widened up where the legs go. And then for it to come out right, I really did want to filament print it. So believe it or not, this takes 27 meters of filament, and that's just for the one bin. So I've got this new modeling concept. I call it modeling while you sleep. Because what I did is I fired it up in the evening, went to bed, woke up the next morning, and the print was just about finished. And better than I could have built it, and I think a lot stronger. So this is what it looks like with the front and rear bins printed. And then the core, you can see it's roofed and all that. In some of my presentations before, I've told you guys that 3D filament is not sandable. I lied. I did the first pass of this with a matte white filament that I had for another job, another project. And I found that the matte filament sands really well. The gloss stuff doesn't, but the matte stuff sands actually really, really well. So between that and then a can of auto primer that's the filler type, I could mask out or sand out most all of the print lines, and came out pretty good. The only problem that I got into now is some of the assembly is difficult because there's no straight surfaces. There's a lot of angles and things kind of tend to be in the way. So I've had to play some games when I started mounting bracketry and components to all this. And the first one was even gluing the legs to the back bin, because you have to have it at the right height. The legs have to be plumb and square and all that good stuff, but you can't get a square in there. And so what I ended up doing, this is the piece that actually goes up here. It's upside down. I clamped this to a tooling block. You can see the clamp up here, put the legs in place, make sure everything was where I want it, and then got some gel super glue, and I would take out a leg, put some gel super glue on the top, put it up inside, make sure it was where I wanted it to be, and then go away for 10 minutes and then come back, do each leg that way. And then once I was done, flip it over and, put more super glue kind of up inside here. But, these Loctite application bottles, I've got one for gel and one for liquid, are really nice for doing it. It's a nice little tip. It doesn't splash all the glue like those cheapy little squeak toothpaste container things. So Home Depot and all those stores have a bunch of those. This was another place where I had to mount some bracketry to support a catwalk. And again, it's hard to hold it in place in space and at the right height, because as you guys know, the stuff going in there crooked looks terrible. So I was able to just space up some blocks and things to get these catwalk supports at the right height. And that's kind of what I'm doing. So like I mentioned, I'm trying to work the two bins of sub-assemblies as long as I can. The only problem is the legs get kind of spindly. So the whole structure is supported, the prototype at least, on some concrete pads. So this is one of my test pieces for a concrete pad. And this was just to make sure I had the leg spacing correctly. This, for people that don't 3D print, this is what the inside of a 3D print looks like. You can specify the infill percentage. You can specify the number of top layers and bottom layers and side layers and a whole bunch of stuff. And I didn't want to waste time and filament on printing top and bottom layers. So this is a print with no top and bottom layers. And the nice thing, this comes out of the printer in about 9 minutes. So it comes out really fast. And if I have to make changes, you know, it's easy to do. So I got the spacing right, the truck fits underneath, and everybody's kind of happy. One of the other support things that I had to do was this piece sticking out of the side of the core. And again, I had to hold it straight and plumb and parallel and level in space. And again, it was difficult to do. So you can't see too well, but this whole thing is suspended on this steel bar. So the bar goes all the way to the other side. And that way I know this is all level. I can square this piece like this and was able to glue it in. So lots of details, lots of things to finish up, but this is kind of where I am right now. And you can see I've got the concrete bases with the top and bottom, you know, actually printed. There is a big block of concrete in the middle between the two things. I think that keeps it from racking side to side because there's kind of no side to side support. So I've got that printed in here. There's a hole in here for wires because I'm going to put lights inside. So that gives me a nice big via to run lighting because this whole piece is hollow inside. So that's kind of where I am today. I'm still working on some details, but after I get, and by the way, this is support for the catwalk. There's a catwalk on top, and you can 3D print something that sticks out about 1 millimeter. So it's to use a technical term, a sticky outie. It doesn't do any other supports underneath. So that gives me a nice square, flat, level place to glue the catwalk onto, because otherwise there's nothing to register. And you know how hard it is to glue those things in place. So after I get this building done, there's a couple other things to do on the project. There's a big tank on the left side. There's a couple taller, smaller tanks that have to get built. There's another tank on the right side. There's a little dust collector in the front corner. There's these additive tanks of all these different sizes that are on the left front side. Here's the back view of it. There's ducting and piping and wiring and God knows what that has to get done. There is a dust collector on the back side that I have to add. There's actually 2 of them. So the problem is I want to finish this thing in my lifetime. So probably going to make some concessions here and there. You know, a lot of the man cages and stuff, there's things from Walters. We've got some pieces from other kits and hopefully they fit. But this is the project. I was hoping that, you know, this was going to go a little faster, but I just see a lot of details and things that are going to take some time. But the nice thing, it's all kind of sub-assemblies and I can just add them over time. So that's the other big project. So this kind of just, you know, chips away as a background project for me. So the last little project, and then I'll stop droning on, is my small little project. You guys know I model like the 20s and 30s, and I like the funky stuff and all that. And a lot of interesting things get built or home built back in the backwoods. And there was a picture I saw, a truck, probably in an old Brian Nolan diorama or something, of like a half track, kind of a half track kind of truck. And Sierra West came out with a similar kind of thing, both in HO and in O. And I kind of liked the truck, but I didn't like the $50 price tag. It wasn't worth quite that much to me. So, yeah, I've been kind of wanting to do this half tracky thing for quite some time. The Lynn truck is kind of interesting. There's lots of prototype photos on the web. You know, they came in different styles. They had things like this, these dump bodies that you could use to even load a gondola, although sometimes the loading didn't go quite as planned. But courtesy of Lawrence Kroll, I am the recipient of a couple N-scale tank kits. And if you take an N-scale tank, tread with road wheels and all that stuff, and cut it down to two wheels, which is pretty much what the Lynn truck has, and glue it onto a Mack truck, now I've got my little Mack truck half track. So a little more weathering and some details, and I've got my funky little half track. So that's what I'm doing. I just have to get back to work and work on my other turntable and work on Milpitas materials, and then maybe work on my home layout. Back to you, Phil.
That was great, Earl. Thank you. That was super. Any questions for Earl? I think the biggest question I have is, what percentage of the conduit do you think you'll do on that cement structure?
I don't know.
That conduit looked to me to be quite concerning to model.
I think I'll do it till I get fed up with it.
Yeah.
You have to have a certain amount of complexity to make it look right. And I think the hard part is like hiding some of the ends, or I don't know. It depends how hard it is to cut and fit everything. I don't want to make a lifetime job of it.
Cool. Well, thanks, Earl. We appreciate that. That was a great update.